Hey guys, Mr. Riz. We're going to start Chapter 2 now. So hopefully Chapter 1 was alright. Remember, there are test corrections if you didn't do too well on Chapter 1 test. Chapter 2 is inductive reasoning and conjecture. So that's where we're going to start at. This first section is mostly vocab to get you guys to know a little bit more about logical thinking and reasoning. Alright, so we'll start with the vocab. First, inductive reasoning. What that is reasoning that uses a number of specific examples to arrive at a conclusion. It is the reasoning based off of patterns. So if you see something that there is not a rule already described for it, it's a pattern or something you've noticed over time, that's inductive reasoning. Next, a conjecture. That is the conclusion that is reached within inductive reasoning. So once we figure out why something is happening based off of that pattern, that is called our conjecture. And lastly, a counterexample is an example that disproves a conjecture. So something that, it's an example, so it's not just explaining how something could be wrong, but giving a specific example of why that reasoning isn't correct. So now that we know some vocab, what we're going to do is sequence the steps of making a conjecture with algebraic terms or geometric terms. So how we determine a conjecture based off of items that we know or really patterns that we see. So first thing we need to do is look for operations or attributes that repeat. So we're going to try to find if there's a pattern somewhere, and that's what we're going to be looking for, making sure that there's a pattern or something that we can see that happens multiple times. Something that we can repeat the process. Then next what we do, ensure all consecutive terms follow the same operation or attribute. So if we think we figured out the pattern to something, like say we think, okay, every single time it's time 3 and subtract 1, we're going to make sure that that pattern continues throughout all the remaining items in that sequence. Then what we're going to do next is make a conjecture. So what we're going to do is, like if it was a pattern, say, alright, the next numbers are going to be this because, and then we give our reasoning. That's our conjecture. Okay, everything is plus 3 minus 2. Then what we need to do next is test the conjecture. So we're going to test to make sure it's right. We test to make sure that the items in the sequence that we think are going to be next are going to be exactly the same, and everything follows. We also try to see if there's any false conjectures, and if there are, we need to repeat the process and start all over again. So now what we're going to do, we're going to write a statement in which you can make a true conjecture, then write another statement in which you can make a false conjecture and provide a counterexample of the false conjecture. So let's start out with a true conjecture, one that we cannot argue, or there's no way of this being false. And we'll do a math one since this is math class. Alright, let's start it out. The product of two odd numbers is an even number. Now that's a true conjecture because no matter how many different numbers we think of, 3 plus 5, 11 plus 33, 191 plus 257, whenever we multiply those two multiply the two odd numbers, we're always going to get an even number. Wait. And we might as well change the mistake that we made. Here we go. The sum of two odd numbers. I don't know why I put product, because probably I was thinking of the next one. Next, a false conjecture. There's plenty, like the one I just put up there, but let's do this one. The product of a negative number and a positive number is a positive number. Now we know that's wrong, but what we need to do is provide a counterexample. And we can't just say the product of a negative number and a positive number is a negative number. We need to give a specific example. So what that would look like is negative 4 times 5 equals negative 20. Now that's an example. That's not a reasoning. It just specifically shows that here we have the product of a negative and a positive number that is not a positive answer. Alright, moving on. Next, a lot of people make mistakes in geometry of thinking of conjectures that can be made and that can't be made based off of specific information declared. So say we have this figure here. It has a triangle with a line cut through it, so we have two separate triangles. And all we know is if BD bisects AC. Some conjectures that can be made are that D is the midpoint of AC, that AD is congruent to DC, and that the measure of AD is 1/2 the measure of AC. Now the reason why we can make those conjectures is that the definition of segment bisector is that a segment or point in a line or plane splits a segment into two equal parts. So conjectures that cannot be made are a couple things. Look like triangle ABC is a right triangle, and triangle AB or angle ABD is congruent to angle DBA. Now the reason why we can't say those is it may look in the picture like this is a right triangle, but just the fact that it's bisecting has nothing to do with triangles. Same thing, a bisector has nothing to do with angles. We could prove that those two angles are congruent if we knew some more information, but we can't just say that because of this fact. Alright, lastly we're going to do some practice with inductive reasoning, and we're going to find the next two items in the sequence and give a reason. So if you want to pause the video, try to think of these on your own, go ahead and do that now. Okay, going through these, the next items in the sequence, the first one should be pretty easy. It should be 30 and 35, and the reason, all you need to do is show me, okay, we're going plus 5. Each time it's being added to 5. And the next one, 1, 6, 3, 8, 5, 10 would be 7, 12. And the reason, well, first it's plus 5, then it is minus 3, and then we repeat that. Plus 5, minus 3, plus 5, minus 3. Okay, the next one, 1, 3, 7, 15, 31. The next items in the sequence are 63 and 127. Reasoning behind that, what it is times by 2 and add 1. The and the plus sign look exactly the same. Alright, so we times by 2 and add 1 to every single term. Alright, next we got 0, 1, 8, 27, 64. Now this is a tougher one. Takes a while to think. What you first want to try is, okay, addition, that doesn't work. Multiplication, nothing there. Start looking at exponents, which if it was squared, it's close. 0 squared is 0, 1 squared is 1, 2 squared is 4, not 8. But you're close if you're thinking squared. What it is something to the third power. So we got 0 cubed, 0 times 0 times 0 is 0, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, so we got to do 5 times 5 times 5, which is 125, 6 times 6 times 6 is 216. Alright, and the last numbers. Hopefully you guys saw this is actually Fibonacci sequence, and so the next numbers in the pattern are 21 and 34, and the reason it's the sum of previous two. One plus 1 is 2, 1 and 2 make 3, 2 and 3 make 5, 3 and 5 make 8. Keep going like that. It's pretty cool. Alright guys, so there's section 1, 2, a lot of vocab, but hopefully you guys can kind of understand it. Next section 2.2, we're going to split up into a bunch of different parts. Alright, good luck.